investigation. We kind of already did one, but let's do another one. Yay. So 10 to the power 3 is 1,000. Yep, 10 to the power of 3 is 1,000. 3 zeros. 10 squared is 100. 10 to the power of 1 is 10. Anything to the power of 0 is 1. Notice that for... What? I don't either. Okay, so anything to the power of 0 is 1. Yeah, not 0. Each time, what are we doing as we go down? What do you notice? Do you notice a pattern? Yeah, it's smaller. What else? You're reading, yeah, you're getting rid of 0, which is the same thing as dividing by what each time?
A number.
Dividing by 10 each time. Okay, we're going down by 10 if we're going from, right, which makes sense. For each power of, if we're adding an extra exponent to 10, we're multiplying by 10, right? 10 cubed is 10 times 10 times 10. 10 to the 4, we're adding another times 10 to that. So as the exponent gets larger, we're multiplying by 10 each time because that's my base. So as we get smaller, going the other direction, we're dividing by 10. So when you take 1 and you divide it by 10, it's what we call 1/10 or 0.1. Okay? So 10 to the power of negative 2, if I take 1/10 and divide it by 10, grab your calculators if you're not sure. 1/10. See if I can, I don't know if I can type it in like this. Let's see. Yeah, it does. And then math, enter, enter. So what I did was 1 over 10. It's better if it's in bracket. 1/10 divided by 10. And then math, enter, enter. Which is 1/100. So what do you think 10 to the power of negative 3 will be? 1 over 1,000. Notice the relationship between 10 to the power of 3 is 1,000. 10 to the power of negative 3 is 1 over 1,000. That's not a coincidence. 10 squared was 100. 10 to the negative 2 is 1 over 100. Cool?
Yes.
10 to the power of 1 is 10. 10 to the power of negative 1, 1/10. So, what's 10 to the power of 4? How many zeros? 4 zeros, so that would be 10,000. Meaning 10 to the power of negative 4 would be 1 over 10,000. Okay. So because that's true, 10 to the power of negative 3, we could also say it's the same thing as 1 over 10 cubed. Do you agree? 10 cubed was 1,000. Do you see what happens with the negative exponent? The negative exponent, what it does is that it moves it from the numerator to the denominator. That's what it does. That's what we did. We moved it to the denominator. 10 cubed, right? Okay, well, we'll talk about it. I also like to call it the reciprocal. Okay, the negative exponent is a reciprocal instead of reciprocal, because reciprocal, like, students often confuse inverse and reciprocal, so that's why I call it reciprocal. Then you know to flip it. So 10,000. This is 10,000 over 1. If I flip it, 1 over 10,000. The reciprocal, reciprocal. Okay. So let me just write that down really quickly. Negative exponents. It's a word I made up. I like to make up words. It's like flip a, no, it's not. It's like a reciprocal. Yeah, reciprocal. Instead of reciprocal, get it? Got it? Yes, okay. So basically, it moves the exponent from the numerator to the denominator and then becomes positive. Or if it was on the denominator, it will move to the numerator and then become positive. So in order to cross that line of numerator or denominator, the sign will change. So in the same way, if I had 1 over 10 to the negative 3, If I want to move, that's the same thing as 10 to the power positive 3. Put it over 1 if we want. When the negative exponent moves or crosses the line, crosses the numerator-denominator line, it becomes a positive. Or if it was on the numerator and we move it to the denominator, the sign switches. Okay? We could also do the same thing with, what if I did x squared? X squared is equivalent to 1 over x to the negative 2. So this was a positive exponent. If I move it to the denominator, it's going to become a negative exponent. So when we move it across the line of numerator-denominator, the sign of the exponent changes. That's what's happening. Okay? Okay, let's do one more. 3 cubed is 27. So notice like 3 to the power of 1 is 3. We're multiplying by 3 each time. 3 squared is 9. 3 cubed is 27. Anything to the power of 0 is 1. Good. Get in there. Okay? 3 to the power of negative 1. 1/3. 1 over 3 to the power of positive 1, or 1/3. 3 to the power of negative 2. So if I want to make it a positive exponent, I'm going to put it on the denominator because it's already on the numerator. If we don't see a, right, it's already. So that becomes 1 over 9. And if I want to take that negative exponent and make it a positive, we move it to the denominator. When it crosses the numerator-denominator line, it switches sign, or 1 over 27. Okay? So, okay, so a to the power of 0. Anything to the power of 0 is? 1. It is 1. A to the power of negative 1. So right now, where is that on the numerator or denominator, technically? Numerator, right? If we don't see a fraction, it's on a numerator. So if I move the a to the denominator, the exponent would be positive. Do you have to write a positive one? That's a really too thick of a pen. Try this again. That's better. 1 over a. Okay? So to move this, how do I make that negative exponent positive? Move it to the denominator. 1 over a squared. And a to the power of negative 3 is the same thing as 1 over a to the power of 3. Okay, so you're starting to understand what a negative exponent does, because that's what you need to walk out of here with the knowledge of. 10 to the power of negative 7. How do I write this with positive exponents? 1 over 10 to the power of 7. Good. How do I write 3 to the power of negative 5? Okay, 1 over 3 to the power of 5. And a to the power of negative n. 1 over a to the n. Okay, so we looked at today in an example. Remember this example, right? If you have, so 5 to the 4 divided by 5 to the 7. So that would be 7 5s we need to write on the bottom. 4, 5, 6, 7. When they reduce, we're left with how many 5s? 3 on the, so 4 of them cancel, we're left with 3 on the denominator. So 1 over 5 cubed, or it's the same thing as 5 to the power of negative 3, which makes sense. 4 minus 7, when we subtract those exponents, what's 4 minus 7? Negative 3. Oh, look at that. It's right here. 4 minus 7 is negative 3. Those boxes are too tiny. Or is it just me? They're pretty tiny. Okay, so a to the power of negative p, I think you're getting the idea, is 1 over a to the p. So that's our very first rule. We're going to talk about 2 rules today. Okay, that's the very first one. Is right there. It's not on your formula sheet. These exponent laws are something you need to know. Yay. So exciting. So, because you have so much knowledge, try E. Okay? Write it with positive exponents and then evaluate it. As in, don't answer, like, if it's like 3 to the power of 2, then make that 9. Okay? Try this. Write it with positive exponents, doing the exact same thing we just did. You done? Or not yet? Did you try? Some of you tried? Come on. So what would this turn into? If I want to make that a positive exponent, where does it go? On the bottom. 2 to the power of 1 is the same thing as just 1 over 2, 1/2. Okay? So, if I want to make that move the negative exponent, where is it going to move? To the bottom. Becomes 1 over 9. Okay, so if we want to move that, right, this is the same thing as over 1. Move it to the bottom. 4 to the power of -3, right? It's currently on the numerator. Where are we going to move it to make it a positive exponent? Denominator. 4 cubed. Does anyone memorize 4 cubed? Yay! Some of you did.
Yeah, 64.
Okay. All right, you can turn the page. Okay, so here's our 2 rules. You have them, right? You know them? Well, actually, I don't like that color, so we'll do yellow. You know I'm facing you and I can see you, right? Okay, good. Same base is being multiplied. What do?
You add them.
Okay, so that equals, 4 to the power of, what's 5 plus -3? 2. 5 plus -3 is 2, and 4 squared is 16. Okay, same base is being multiplied. We add the exponents. 2 plus -5. -3. Okay, we want to express our answer with positive exponents. Express the answer with positive exponents and then evaluate. So, how do I make that a positive exponent? Move it where? Yes. Good. And do you remember what 1 over, do you know what 3 cubed is?
Yeah.
No, I told you to memorize it, remember?
It's 27.
27.
No, you're kidding. You're cheating. I know.
Okay, right now the negative exponent is on the denominator. Where do I move it to make it positive? The numerator. So it becomes 2 to the power of 5. You don't have to write divided by 1. And does anyone know what 2 to the power of 5 is? I don't expect you to know this one.
39.
32.
That was pretty close.
Well, except for 39. 9 is not even divisible by 2. Okay, so same bases. Now, same bases being divided, what do? Subtract. Be very, 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 very careful. Because, why? Why do I have to be very careful here? Hi, they're negatives, and you're subtracting a negative. What happens when we subtract a negative? -7 plus 5. Yeah, 2 negatives make a positive. -7 plus 5?
12. -2.
-2. Okay, problem, we want to answer with a positive exponent, so where do we have to move it? To the bottom. So 1 over 6 squared is the same thing as 1 over 36. Bigger. Let's make it a little larger there. Okay, power to a power. What do we do if you have a power to a power? Multiply. So it becomes 2 to the power of -3. 3 times -1, yeah. And if it's negative, where does it move to become positive? The bottom. 2 cubed. 8. 1 over 8.
Keep quiet here.
Okay, skipping 2, let's go on to 3. So let's try the same idea, but with variables. Same bases being multiplied, what do we do? Nope. Nope, not. We add the exponents. When we're multiplying same bases, we add the exponents. So negative 4 plus negative 3 is actually negative 7. Yes, but that's not okay because we never want to leave exponents negative. We always want to answer with positive exponents. So that's actually 1 over 8 to the 7. No one's stupid. Okay, something like this, what I recommend you do is actually rewrite this. If you have a division symbol, we don't use that really anymore in high school. We just draw a line and yeah, okay. So we want to do that because 6 divided by 2. So when we divide, we can now divide our coefficients. 6 divided by 2, 3. And when we divide same bases, what are we going to do with our exponents? Subtract. 2 minus 7 gives negative 5. Now this is my favorite part. Okay? There's one of two options. The answer is going to be either this or it's going to be this. Which one? Okay, I hear second, I hear first. Let's discuss.
I hear third.
Okay, which one would you... Okay, let's think. The negative exponent, who is it being applied to? Is it being applied to both of them or just the x? Just the x, meaning only the x is going to move. So if that's the case, which one's correct? The second one. The second one. So the answer would be 3 divided by x to the power 5. So the reason why is this power, this exponent that's negative right here, is only applied to the x. Let me show you the difference. If it looked like this, then the whole thing would go on the bottom, because that negative exponent applies both to the 3 and to the x. Without those brackets, it's only being, that x to the power, that negative exponent is only for x. So only x moves. Okay? This one's interesting. Now I'll give you two strategies. Okay? With this, when you have the same basis being divided, we subtract the exponents. You have to be careful. So whenever you're subtracting negatives, right? So if you subtract the exponent, 6 minus negative 5, what does that give you? You subtract a negative 5. It becomes a plus what? 6 minus negative 5 is equal to 11. Okay, yeah, 11. So that 11 is on the numerator. The 2 is still on the denominator. Because whenever we're subtracting exponents, that's the new numerator. Now another way to solve this, because that might be kind of confusing, is remember we talked about if you have a negative exponent, we can move it. So this y to the negative 5, we can actually move it. Because it has a negative exponent, we can move it where to make it positive? To the numerator. We move it across the line, and the sign would change. So another way you could think of this problem is we can move y to the 5 up to the top for it to become positive. We only move the negative exponent, because positive exponents we're happy with. So only the negative exponent, I'm going to move it to the top so it becomes a positive number. And now, same bases being multiplied, what do I do with my exponents? Add them. It gives me the same thing of y11 over 2. You could have also wrote this as 1/2 y11, because the coefficient right here is a 1, right? So you could have also done that. So, yeah. Right? Because dividing by 2 is the same thing as multiplying by half. Your brain hurt yet? Yes, a little bit. How are we doing? Okay. Could you imagine trying to do like some of yesterday's stuff and this? Too much. All right. So this -3 applies to who? Everything, both of them. So we're going to write it separately. -2 to the power of -3 and x to the power of -3. Oh, I guess we could, I'll show you after. So -2 to the power of -3. So to make it positive, where are you going to move that?
On the bottom.
On the bottom. So -2 to the power of 3. And we're going to move x to make it a positive exponent. Actually, that used to be my old analogy. It's like it's like your passport to cross. So once, yeah. Yeah, but. Okay, so it's like the border. So we're going to the U.S. I'm just going to say that from now on. There's nothing, well, I don't know if there's anything wrong. Let's not go there. Negative. It is, but it's not Canada. -2 to the power of 3, what does that equal? -8 x cubed. Okay. So here's the thing. We applied the -3 to both, right? We could have also, see this negative exponent? We could have moved it all to the power, all to the, right? That negative applied to everything. So everything moves to the denominator to become positive, or to the US. Yeah. And then bringing in the power of 3 still gives you that same answer. Okay. The thing with exponent laws, there's more than one route you can take, which makes it confusing. Sometimes when there's only one route, it's easier, right? Okay. 8 divided by 4, what's my coefficient? 2. That reduces to 2 over 1, right? So it's just a 2. So we have a 2 in the numerator. Do you have to write a 1 for the denominator? No. Where would I move the a so it becomes positive? To the bottom. So in the denominator, we'll now have an a to the 5. Where do I move b, because it has a negative exponent, to the top? So b cubed. I guess it's not the same color. Make sense? So because it had a negative exponent, we moved it up so the exponent was positive. So it just crosses the line. Yes, yeah. So here in F, notice the negatives applying to both the 5 and the P, right? Because it's inside the brackets. So we can move that entire thing down. The problem is, if I move this entire thing down, first of all, what the exponent will be, positive or negative? Positive. We're moving it across the border. It's now positive. Changes the sign. Is 5q to the 4 still on the denominator? Yes. It didn't have a negative exponent. It stays where it is. So what's left on the numerator? 1. 1. It's the invisible coefficient kind of thing. 5 squared. 25 p squared times 5q squared. If you have 5 quarters, how much money do you have?
I have 125.
125. Because I multiplied it by 5. Right? 125 times 5? Yep. I have no idea. That's a really good question. It was an accident.
Oh, I was like...
That's why you guys were being like, what? Yeah, that makes more sense. Why you were being like, what? I thought you were asking about... Yeah, I'm okay, thanks. Okay, I thought thought you were talking about 25 times 5, but no, you're talking about where did my 4 go? Just disappeared. Magic. Alright. A miracle occurred. Let's turn and look at the next page. I guess it's open for you, right? So, hey, that looks like fun. There's nothing like stepping it up a notch, hey? It's okay, guys. Here's homework. No? Did I write the wrong one? The last one? Did you miss? 1 second. Oh, no, that's not good. Okay, here we go. We're going to do this one together. Okay? I'm going to turn this guy into a fraction. When I say this guy, talking about that guy. Okay, so what I mean is, I'm going to rewrite it so that it only has positive exponents. So how do I write that so it only has positive exponents? Who's staying on the numerator? The 5 and x cubed. Who's moving to the denominator? Y will become a positive 8 because we're moving it down, and z to the 2. Okay? Divided by. We'll fix that later. So we're going to rearrange this. We're going to move anything with a negative exponent. We're going to get it to cross the border to become positive. So 15 stays the same. X to the 8 stays the same. Y cubed stays the same, right? And on the denominator, x to the 5 stays the same, and z squared stays the same. Who are we moving? Yeah, the y negative 3 and the z negative 1. Okay, so the z negative 1 is going to move down.
Yes, right.
And the y negative 3 is going to move to the Canada. Yeah, yeah, exactly. We are above United States, if you're not sure. There's a geography lesson for you. You think your social teacher can thank me. Okay, when you divide fractions, we change it to multiplication. I think some teachers say kiss. No, keep, switch, flip. No. Keep the first fraction, switch to multiplication, and flip the second. Keep, switch, flip. Right? You multiply by the reciprocal. When you're dividing fractions, we multiply by the reciprocal. So we're going to multiply by x. Keep, change, flip. Yeah, that's what it is. Keep, change, flip. Let's combine z squared and z to the 1. What could you write that as instead? Z cubed. And here, 15. X to the 8, we can write this instead as y to the 6. 6. Because I took the two, here, there's my highlighter. I took these two z's, z squared and z, and made it z cubed. Okay? All right, when you multiply fractions, what do?
You multiply them.
Straight across, right?
Yes.
So let's go straight across. This is not so bad, is it?
It's pretty hard.
Is it requiring you to know like previous knowledge?
Yeah.
Absolutely. You need to remember how to divide fractions. You need to remember how to multiply fractions. Yeah. Okay. So 5 x to the power of what? 3 and 5? 8. Z cubed divided by, what's the coefficient? First, put the coefficient. 15. How many x's do we have? 8. How many y's? 8 plus 6. 14. And z squared. Okay. We're almost there. We can simplify some stuff. Can you believe it? Okay. 5 over 15. What does that reduce to? 1, and you're right, no more x's. The x's are gone. Gonzo. So we're left with, so far, we have a 1 and so 3 on the denominator. The x's are gone. The y's, are they going to stay on the denominator? Can we simplify them? No. So there's just 14. Now there's 3 z's on the numerator and 2 z's on the denominator. That simplifies. What does that simplify to? 1 z where? Yeah, because there was 1 more on top than the bottom. So 1 z. You did it! You survived and did not blow up. It's amazing. Okay. We are literally this close to being finished. I need your attention for just like 2 more minutes. Okay? Here we go. Almost done. 2 to the power of 2/3 to the power of -4. So because it's all negative, we can move that entire thing to the denominator. But that's kind of confusing, right? Who would do that? Another thing we could do is just apply the negative to both. Would you agree? Because that exponent applies to both numbers. So where are we going to move the 2? To the denominator. And where are we moving the 3? To the numerator. Would you agree that's the same thing as 3 over 2 to the power of 4? Should I go through that one more time? Yeah. Okay, I'm going to go through that one more time. Okay, ready? So, I'm going to apply the negative exponent to both. Because the power of -4 applies both to the 2 and to the 3. Okay? Now, because they both have negative exponents, they're both going to change positions. The 2 to the -4, we're going to move it down so that it becomes positive. And the 3 to the -4, we're going to move him up so he becomes positive. They need to cross the border, each one of them. So 2 to the -4 is now going to move to the bottom. And 3 to the -4 now moves to the top so that they become positive exponents. Once they cross the border, they become opposite signs, right? Is that the same thing as 3 over 2 to the power of 4?
Yes, it very much is.
Yes, it is. It very much is. So notice the difference between this and this. First of all, what do you notice about the 2 fractions? You flipped it, and what happened to the exponent? Changed to a positive. And so that's the last rule, or law, exponent law, is if you have a to the power of a over b to the power of -n, it's the same thing as b over a to the power of positive n. We flip the fraction, and it becomes a positive exponent. Because you're basically moving both positions, right? It's the same thing. We're done. I don't think there's any more, right? No. Yay. Okay, so your assignment. Circle these. 1, A, C, E. Remember, this is the minimum amount. Some of you are really good at doing lots. Number 2, 3 to 6 ACE, so 3 ACE, 4 ACE. You can do more, but this is the minimum. 5 ACE and 6 ACE. This is on your outline that you got, but it's easier if you just circle them, right? Okay, so 7 is a weird one. A, E, and G. And then, no 8. 9 to 10 ace. So 9 ACE. And then 10 ACE. Where's my E? Here it is. Okay. And then 12 to 13 B and D. So skip 11. Look at that. You're welcome. You're welcome to do 11. They're great questions and great practice. 12 B and D. And 13 B and D. And then I would like you, especially if you have time, like these are going to be, hey, where's 14? I don't have a next page. It's gone.
Yes.
Okay, 14, B, 15 to 17 if you have time. They're good practice. But make sure you get the other stuff done, okay?